Introduction to cloud formation. Clouds are fascinating atmospheric phenomena that play a crucial role in weather patterns and climate. They form when water vapor in the atmosphere condenses into tiny droplets or ice crystals, creating visible masses of moisture. Understanding how clouds form and what they are made of helps us grasp their impact on weather and climate. The process of cloud formation. Cloud formation begins with the evaporation of water from surfaces such as oceans, lakes, and rivers. As water vapor rises into the atmosphere, it cools down. When the air reaches a certain temperature, called the dew point, the water vapor condenses into tiny droplets or ice crystals around small particles called condensation nuclei. These particles can be dust, salt, or pollutants that provide a surface for condensation to occur. Types of clouds. Clouds are categorized into different types based on their appearance and altitude. The main cloud types include cirrus clouds. These are high-altitude clouds that appear thin and wispy. They are composed of ice crystals and often indicate fair weather or the approach of a weather front. Cumulus clouds. These are puffy, white clouds with a flat base. They form at lower altitudes and are associated with fair weather, although they can develop into larger cumulonimbus clouds that produce thunderstorms. Stratus clouds. These are low, gray clouds that cover the sky like a blanket, often leading to overcast conditions and light precipitation. Nimbus clouds. These are thick, dark clouds associated with heavy precipitation. Nimbus clouds, especially cumulonimbus, are capable of producing thunderstorms, rain, and other severe weather. Cloud composition. Clouds are made up of millions of tiny water droplets or ice crystals. The composition depends on the altitude and temperature of the cloud. Water droplets. In warmer clouds, water vapor condenses into liquid droplets. These droplets are so small that they remain suspended in the air, forming clouds. Ice crystals. In colder clouds, water vapor sublimates directly into ice crystals. These crystals form the basis of cirrus clouds and can combine to create larger snowflakes or hailstones. The role of temperature and humidity. Temperature and humidity are key factors in cloud formation. As air rises, it expands and cools. If the air cools to its dew point, condensation occurs, leading to cloud formation. High humidity levels increase the likelihood of cloud formation, as there is more water vapor available to condense. Cloud development and movement. Clouds can develop and change over time due to atmospheric conditions. For example, cumulus clouds can grow into towering cumulonimbus clouds if the atmosphere is unstable and supports strong vertical development. Clouds are also carried by wind currents, which can move them across vast distances and affect weather patterns in different regions. The impact of clouds on weather. Clouds play a significant role in regulating the Earth's temperature. They can reflect sunlight back into space, which has a cooling effect, or trap heat radiating from the Earth's surface, contributing to the greenhouse effect. The type and thickness of clouds influence the amount of solar radiation that reaches the ground and the amount of heat retained in the atmosphere. The water cycle. Clouds are an integral part of the water cycle. They form from evaporated water and eventually release moisture back to the Earth's surface as precipitation, including rain, snow, sleet, or hail. This precipitation replenishes water sources and supports ecosystems. Conclusion. Clouds form when water vapor in the atmosphere cools and condenses into tiny droplets or ice crystals around condensation nuclei. The type of cloud formed depends on the altitude, temperature, and humidity of the air. Clouds play a vital role in weather patterns, temperature regulation, and the water cycle. Understanding cloud formation and composition helps us predict weather conditions and appreciate the complex interactions within our atmosphere.